Ladies and gentlemen, please welcome Dean Hakamovich.
Good morning. I am honored to represent the Internet Explorer team today to talk about the browser and HTML5 applications. When we started looking deeply at HTML5, we saw that it enabled a whole new class of applications. These applications will stress the browser runtime and hardware, as today's sites just don't. We quickly realized that doing HTML5 right, our intent, was more about designing around what HTML5 applications will need, rather than a particular set of features. Done right, HTML5 applications will feel more like real apps than web pages. And our approach to HTML5 is to make standard web patterns that developers already know and use just run faster and better by taking advantage of PC hardware through Windows. We planned IE9 from the ground up to enable professional-grade HTML5 on modern hardware. Because HTML5 apps will be so important, we want to talk about 5 things today. Performance. HTML5 applications will need great script performance. Standards. Developers want the same HTML, the same script, the same markup to work. GPU-powered HTML5, because HTML5 applications will be graphically rich and interactive. We'll talk about the IE9 platform preview and community, because we will build the next web together. And number 5, well, we'll see it when we get there. Now, we can have these conversations today because of several great things that have happened over the last year. A year ago at MIX, we released Internet Explorer 8. And in the last year, it has become the most used browser on the web. Windows 7 released, and the creativity and innovation in the hardware ecosystem has been absolutely tremendous. Now, last and definitely not least is the decline in IE6 usage. Now, there was a funeral last week in Denver. There was a funeral last week in Denver. The IE9 team couldn't make it. We sent flowers. Seriously. And, you know, we're puzzled. We're on our 3rd major version since Internet Explorer 6. The world has changed in so many ways since August of 2001 when IE6 first released. You know, I think of Facebook and YouTube. I'm sure you have your own examples of how the world's changed for you. Now, we have recommended upgrading from IE6 to IE7 and now to IE8 for years. We will continue to support Internet Explorer 6 with security updates. That's just one of the responsibilities of Windows. We are excited to get users off of IE6 to Windows 7 and IE8 and then on to IE9. And I thank you for being part of this movement. All right, let's talk about performance. HTML5 applications need great performance. Now, at the Professional Developers Conference in November, we talked about how different sites use the browser differently. And looking at this chart, you can see that the percentage of time that different sites spend running JavaScript varies greatly. And that's the gray boxes down at the bottom. What's important here is to look at the entire system when thinking about browser performance. These large orange boxes, blocks at the top, represent a great opportunity for the operating system and hardware to pitch in and make the browser faster. Let's talk about JavaScript in particular. WebKit.org publishes a benchmark called SunSpider. Let's see how IE9's new JavaScript engine compares. So IE9's new script engine you may have heard of it by its internal code name, Chakra, is faster than many browsers. One thing to keep in mind is that we've done very little SunSpider-specific work at this time. We will continue to improve IE9 script performance. It's interesting to note that the gap between IE9 and some of the other browsers to its right is about an eye blink. It's about 300 milliseconds. And it took 70 seconds to identify that 300 millisecond difference. Now, the real question now is, how do we make JavaScript even faster? Because these SunSpider scores are all converging. Our approach is to use modern PC hardware to its fullest. Now, Chakra is different from other JavaScript engines. It compiles the JavaScript in the background on a separate core of your CPU, in parallel with the IE process. So your dual or quad-core machine is put to good use running the web faster, without having to make any changes to your pages or code. Now, let's talk about how the web's changed over the years. In the beginning, the web had lots and lots of HTML and little pieces of script here and there. And an interpreter was good enough for that. Over the years, different browsers have added jitters and different kinds of jitters. Many different kinds of jitters. The problem with JIT today is that so much time and energy goes into managing the time and scope that the jitter operates in. If basically users wait. Users have to wait if the jitter jits too much, because the jitter is sitting there compiling the code and you don't get to run it. And the user has to wait if the jitter jits too little, because then the jitter did a little bit and the user is stuck running a slower interpreter. Compiling in the background puts hardware to use here without having to recode the site. And the key here is to bring the best technology to the most important language you use, JavaScript. All right, let's transition over to IE9 and standards. Developers want to use the same HTML, the same script, and the same markup across browsers. That's the goal of standards and interoperability. No need for different code paths for different browsers. And that's a key goal for HTML5. We love HTML5 so much, we want it to actually work. In IE9, it will. We want the same HTML, the same script, the same markup to just work across browsers. And so in IE9, we'll do for the rest of the web platform what we did for CSS 2.1 in IE8. Now, at the same time, we want to be responsible about the standards that are still emerging, the standards that are in committee, and the standards that are partially implemented, often in different ways, across browsers. And so to make decisions on this front, we started from data. So we set out to support every standard we saw in real-world data. IE9 will also support several standards that are not represented in this data, and we're going to do that to complete the scenarios that HTML5 applications will need. Now, let me explain this chart. We wrote a tool, and it navigated 7,000 sites, and it recorded all the script activity that happened in these top 7,000 sites. The #1 API used, index of, 94% of these sites. Get element by ID, which I'm sure all of you use, number 13, 80%. We found that script changed CSS opacity on elements a lot of the time. Now, the most broadly used API that's not in IE8 that you'll see on this chart is Add Event Listener, number 17, with 65% usage across these sites. Now, because we started from data, what developers like you really use was our starting point for what to support. All right, so now let's take a look at some of these, at some examples in action. All right, so I'm going to come over here, and you've got a few browsers lined up on your screens. And I'm going to start over here. This is Firefox, and here's some of the markup in the page.